Okay, so during this lab today, we're going to look at what happens when we mix an acid and a base together and look at the results of that. So the first thing that I'm going to do is I'm going to take 10 drops of hydrochloric acid. And I'm going to add a drop of universal indicator. And if we compare that to the color chart, we can see it's kind of in that pink-red range. It's definitely below 7. 7 is neutral, and anything below 7 would be considered an acid. This looks like it's probably in the 2.5 to 3 range. So that's showing that hydrochloric acid is indeed an acid. Beside this, I'm going to do 10 drops of water. And when I add the universal indicator to the water, what do you expect the color range should probably be for that? If you look at this, we're going to get kind of this greeny yellow color. And if we turn this a bit, we can kind of see that matches close to the 7, maybe a 7.5, which is what we would typically expect for regular tap water. So we're seeing something that's kind of in the neutral range. What I want to do is I'm now going to take some potassium hydroxide. Potassium hydroxide, if you remember from your lab the other day, is a base. And I want you to watch what happens when I add the potassium hydroxide to our hydrochloric acid, which is an acid. We're going to just do this one drop at a time. So we've got one drop we're going to put in there. I'm going to use my dropper to kind of stir it up a little bit. Then we're going to do 2 drops, stir again. Not too much happening going on here. 3. Drops. 9. You see a whole lot going on here? Anything with our color change going on? Okay, well, so we got up to what, about 10 drops there. So we didn't see much of a change happening where, many people would expect, okay, we have an acid, we're adding a base to it, that something's going to kind of change there, but it still appears that we're getting something that falls in the acidic range. What I want you to do is to take a couple minutes, talk with your table partner, and think of what kind of investigation we could do to find out how many drops of potassium hydroxide it would take to actually neutralize 10 drops of hydrochloric acid. So take a minute with your table partner and discuss what we could do. Okay, so now most of you have had the chance to talk with your table partner. Many of you have basically just come up with, okay, we can test this by, putting 10 drops of hydrochloric acid in our tray and then gradually adding the potassium hydroxide and counting the number of drops it takes to become neutral. So that's what we're going to do. We're going to go ahead and we're going to use the big cup here. Drops of hydrochloric acid. We're going to know when it's been neutralized because we're going to add our universal indicator. We can tell we've got an acid there. And then we're just going to basically start to count how many drops of potassium hydroxide it takes to neutralize this. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Got some 15. We're starting to see something going on here. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 28, 29, 30. I see a little bit of color change starting to happen here, but it's still definitely got the pink going on. Let's keep going. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. I see some more starting to kind of show up here. 41, 42, 43, 44, 47, 48, 49, 50. And what kind of color would we be looking for to know that it has become neutral? Definitely something in this yellowy green area. Correct. 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. Oh my goodness, we've got 60 drops. Oh, hey, looky here. We're starting to get something faint. We're starting to get kind of a yellowy color. Let's do a little bit slower this time. So we've got more in that yellow range. We've got 60, 61. Oh, 61's maybe too much to turn purple there. Look at that with just 61. So 60, we had the green. 61, it went a little bit more into the basic range. So 61 would definitely be where we would want to say that was too much. So 60 drops of potassium hydroxide to neutralize 10 drops of hydrochloric acid. Do you think the reverse would be true? Do you think if we took 10 drops of potassium hydroxide that it's going to take 60 drops of hydrochloric acid? Well, let's try. So I'm going to have to use a small section of the tray now. Let's go right here. I'm going to do potassium hydroxide this time and do 10 drops of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 potassium hydroxide. We're going to put 1 drop of our universal indicator in. So we definitely see this is definitely a base. If we look at it here, it's very kind of purpley. I'm going to go, that's a hard tell, 11.5 maybe to a 12 for this base. Again, we're going to start counting how many drops of hydrochloric acid it takes this time to neutralize the potassium hydroxide. So it took 60 potassium hydroxide. Let's see if it takes 60 hydrochloric acid to make it become neutral. Got 1, 2. Oh boy, it's already changing. 2. Just going to stir it a little bit. 3. Oh boy. And look, after 3 drops, it's already to an acidic state. So between 2 and 3 drops of hydrochloric acid, it basically even skipped over, 10, 9, 8, 7, 6. We're already down into the acidic range, and it only took 3 drops. So if you think about this, the difference between when we added hydrochloric acid to a base, and how quickly it only took less than 3 drops to neutralize it here. And when we did the had that started off with the hydrochloric acid up here and added the potassium hydroxide, which was a base, it took 60 drops in order to do that. So we're going to take some time and look at some of the analysis questions on this section and to think about, why that happens and what that tells us about the strength of these 2 particular chemicals.